So welcome back. So today let's start discussing about Numpy. So Numpy actually is a very famous library in terms of data science and data analytics. When you're performing some data analytics, when you're performing some kind of statistics, for all these kinds of operations, Numpy plays a major role. So first, let us understand what exactly is Numpy first. Then we'll proceed discussing about various libraries and functions available, or a lot of functions available in Numpy. Okay. So basically, NumPy here, when I say NumPy, NumPy stands for numerical Python. Numerical Python. So when I say numerical Python, you can perform a lot of numerical operations using NumPy. If you want to perform some kind of advanced numerical operations, we can use NumPy. Apart from the advanced numerical operations, you can also use NumPy. Mainly NumPy is very famous for working with arrays. Okay. So what is an array? First thing before talking about NumPy as a data structure called as array, and we'll be using arrays a lot in NumPy, we should understand what exactly is an array. So let's understand what exactly is an array. See, in our previous sessions, we understood about various other data structures like list, tuple, dictionaries, and set, right? So in the same way, array is one of the kind of data structure where it is nothing but group of similar elements. Group of similar elements means what happens here when you talk about list was group of dissimilar elements, right? But array is nothing but group of similar elements, so we can have elements of same data type. Okay, we can similar elements. When I say similar elements, and moreover I'm talking about homogeneous array, let's talk about heterogeneous array later on. So when I say similar elements of same data type, elements of same data type. So same data type means maybe all data type might be strings or float or maybe integer, something like that. So elements of same data type is nothing but called as similar elements. So group of similar elements or collection of similar elements is nothing but an array. Okay. So in NumPy, we will be mostly working with arrays. Not only a single dimension array, we'll be working with multi-dimensional array. That is the main reason of using NumPy. So when I say multi-dimensional array, your matrices come into the picture. So we'll be using matrices, we'll be using data frames. Of course, data frames we'll be using in pandas, but those kind of data structures we'll be using in NumPy, and table-like structure we can say, where we'll be having rows and columns. And NumPy has a lot of functions which can manipulate your array. You can work with a lot of matrix-based operations you can perform using NumPy. Okay. So before that, let's talk about how do we create array using NumPy, because as we talked that NumPy is very famous for using arrays, and we have understood that NumPy has a lot of operations for working with arrays. First thing is we'll understand how do we create array using NumPy. That's a very important point. Okay. So how do we create an array means, in NumPy, we have n number of functions to create an array. Let's discuss few functions which will be helping us to create an array. The very first function is array itself. Okay, in NumPy, we have a function called as array to create an array, to create a NumPy array. And apart from array, we have also other functions like we have linspace. Linspace is one of the other function to create an array. Arrange is one of the function to create an array. We have something called as log space to create an array. We have something called as zeros to create an array. We have ones and random.rand for creating some random numbers. So etc. I can say here we have a number of, these are the few functions. There are some more functions, but these are the few functions which will be helping us to create array using NumPy. Let's start with the very first function array and explore how to work with the array. Okay. But before that one, we have to import NumPy in your code. So let's import NumPy first. Okay. So I'll just say import NumPy as NP. And moreover, guys, as we have installed Anaconda platform here, and you know that Anaconda platform is mainly for data science. It's a data science toolkit. So there is no need of installing any packages which are related to data science. Most of the packages which we are discussing will be inbuilt in Anaconda. Okay. So in the same way, NumPy is also inbuilt. So no need to worry about reinstalling NumPy library. So you can see right now my NumPy library is perfectly imported. Now let's start. So if you want to create an array, you can just simply say np np dot. So np is the alias name for numpy. So as we have said as np. So np dot array. Okay, np dot array. Array is a function to create a numpy array. So np dot array. In this, you can actually give your. So basically, if you want to create an array, you can give your elements in an array. So what kind of elements you want to give? So for example, now I can give a list to convert into an array. So let me give a list of elements. So right now I'm giving all elements as integers itself. Okay, I'm giving all the elements as integers, and these are an numpy array looks, guys. Okay, these are an numpy array looks. Now I'll just save this in a variable. I'll just say arr is equal to np dot array of so and so elements I'm having. So right now in my variable called as arr, your numpy array is saved. Okay, this is how simply you can create an array. Let me show you the type of the array right now. You can simply say type of arr, and you can see that it's a numpy n dimension array. Right now, whatever we have created, right, guys, it's type of n dimension. So whatever we have created, it's a one dimension array. So whatever dimension it is, the type will be numpy nd. Nd means n dimension array. Okay, nd stands for numpy n dimension array. Perfect. Now, right now we have created a one dimension array. So why I'm saying it is one dimension? How can I say it is one dimension? Means you can clearly see I'm having only one single kind of a row. Okay, one single row and maybe multiple columns, we can say, or we have a one single elements, one single bracket of elements. That is nothing but your one dimensional array. But how do a two dimensional array looks or three dimensional array looks? We'll see that. Okay, how one dimensional array is different from two dimensional array. So I can say here we have only one axis, right? More clearly, as we have only one axis, it's a one dimensional array. Okay, we'll talk about two dimension, three dimension more clearly. But first, let us complete this one dimensional array. Okay. Now, basically, in array, guys, we have a lot of n number of attributes here. Okay, let's talk about that first. Okay, so we can simply say arr dot. Here we have an attribute called as ndim. Here ndim stands for number of dimensions. So if you want to find out the number of dimensions of an array, you can use ndim. So you can simply say arr dot ndim. It will it's an attribute, not a function. So it will tell you the number of dimensions of your array. So you can simply say arr dot ndim, you'll be getting one. So without you looking at the array, if you want to know the dimensionality of a numpy array, you can use arr dot ndim. You will be getting the dimensionality of the numpy array. Next, if you want to know the shape of the array, so you can simply say arr dot shape. You'll be getting 6. Right now, as it is a single dimension array, you are getting 6. But what shape tells us? Shape tells us number of elements in each axis. Okay. Right now, we have only one axis. Okay. Here we have only one axis, that is your this particular axis. Maybe you can call it as x-axis. So as we have only one axis, or axis 0, we generally call it as. Okay. As we have only one axis, the shape is only one, means you'll be getting 6, that's it. But if you have 2 axes or 3 axes, you'll be getting the number of elements in each axis. Right now we have only one axis, that is we have 6 number of elements in that particular axis 0. That's it. And we also have ar.size attribute. This particular tells us the number of elements in the entire array. See, you might assume that shape and size both are same. No. For a one dimension array, shape and sizes both are same, because in one dimension array we have only one dimension, so it will return 6. But size returns as number of elements in the entire array, irrespective of the axis. Okay, number of elements in entire array. So it will return the number of elements in entire array. Okay, not for a specific axis. So if you want for a specific axis, you can use shape. If you want for the entire array, you can use size. As simple as that. Okay, like that, shape and size will be telling us. But before talking about shape and size, we should understand what exactly is dimensions. In general, guys, you might heard about what we call. You might heard about dimensions. I mean, we have seen a lot of graphs, right? So, for example, in a graph, if you have only one axis, for example, let's assume that we have only one axis. We call it as x-axis, right? We would generally call it as a x-axis. So when you have only one axis, it's a one-dimension data, as simple as that. So here we can plot this particular data. Maybe if I want to show this particular data 1, 2, 3, 4, 5, 6. So I can show like this: 1, 2, 3, 4, 5, 6. Right. For example, if I want to show two-dimension data, if I want to have two-dimension data, then you'll be having two axes. You'll be having x-axis and you'll be having the y-axis. So when you have more than two axes, or when you have two axes, it's obviously two-dimension data. So here you have a x-axis, here you have a y-axis, right? Here you have y-axis. But if you want to show more than two dimension, maybe three dimension, also you can show. So three dimension will be something like this. X-axis will be having, obviously z-axis will be having, and obviously y-axis will be having. So we'll be having multiple axes like this. I can go on, obviously. So maybe you can assume this as x, y, and this as z, something like that. Okay, so like this you'll be having your three-dimension data. Okay, so right now we are working with only one-dimension data, but if you want to go two-dimension, three dimensions, we should see. Okay, first let us complete the one dimension in that way. So now, yeah, so that's the reason we got ndim as 1D. Okay, perfect. Next, now let's see the D type of a array. So basically the type of the numpy array is numpy.nDimension, but if you say D type, so if there is an attribute called as D type, you'll be getting the data type of each element in an array. So we know that right now we have created an homogeneous array, means elements of same data type, right? So if I say ar.d type, you'll be getting int 32. So basically our data type, our data is of integers, you know, right? Our elements is of integers, and it's a array, and it will be group of similar elements. So all the elements are of integers, and this, what is this 32 actually? This 32 indicates that our memory, okay, how much memory your array is occupying. Okay, basically every integer has its own memory. Basically we have different types of integers. We call it as int 8. Int 8 is starting one. Then we have int 16. Then we have int 32. Then we have int 64. So what is this 32, 8, 16, 64? Okay, it's a memory. Okay, it's a memory. Now if I talk about, I'll start with int 8. Okay, let's start with int 8. So int 8 means what? It stores 8 bits of memory. Okay, so this particular 8 indicates 8 bits. 8 bits. So when I say 8 bits, obviously it is 1 byte, right? 1 byte. So as it is only storing 1 byte of memory, that is 8 bits, the range of integer is something like minus 127 to 127, something like that, 128, something like that. Okay, so the range of int 8 is only this, means it can store only these particular elements. If it is going on, if you proceed with this, if you're storing your data in int 8, and if you are going beyond 128 number, or below 127, minus 127 number, it cannot store. Okay, let's see a small example here. Okay, so what you can do is, we can just simply create an elements of that particular, this one. And when you're creating a numpy array itself, you can tell us, we can tell whether you want to use int 8 or you want to use int 16. By default it will be int 32, but for example if you want to use int 8, you can use that. So D type, so it's useful a lot when you are using a less number of numbers, guys. For example, let's assume that you know that your data is storing only range of data between minus 127 to 128. Okay, if it is storing only between that particular range, then happily you can use int 8 only. But if you feel that if your data is more than that, means if you know that your data is more than that, in that case you have to go for int 16 or int 32. So in that way you can save your memory a bit. Okay, so by using this particular way, when you have large number of data, this particular will be helping us a lot to save your memory. Okay, so in this way, if I want to make my array int 8, so let's say like this. Okay, in this particular same function, I have to use one more attribute called as D type, and I have to explicitly tell that I have to use int 8. So if I say like this, my array of D type will be int 8. If you see here, you can see it is int 8. And if you say AR or D type, it is int 8. By chance, if I store 128 here, 128 is also not possible. 127, up to 127 is possible. Okay, so 127. Okay, it is minus 128 to 127. Okay, so it is minus 128 to 127. So you can see 127 it is able to store. But if I store maybe 500, okay, let's assume I'm storing 500. So you can see 500 is not properly present here because of the range. So it will convert into binary. Basically, it converts into binary, and the binary code for this is minus 12 because of that. it's not proper because your range was int 8 and int 8 is between minus 128 to 127. That is the reason it is beyond that. That is the reason it is not storing that. I mean, it's not proper. So in that way, if your data is beyond this range, I would recommend to go to int 16, obviously. Okay. So int 16, it's like a 16 bits, means 2 bytes. The range increases. It is between minus 32,000 to plus 32,000 some range. So you can just see. So for this range, you can just go to online and just check, guys. There is a very good website which tells us the ranges. Okay. So we just search for int 8 range, you'll be getting this. You can see int 8 is approximately between minus 128 to 127 as we discussed already. And we also have something called as unsigned integer. Unsigned integer means you'll be having only positive values, no negative values. So between 0 to 255. And int 16 is between minus 120, minus 32,000 to plus 32,000. So you can go on. If you just click on this link, you can see the other ranges also. What are the other ranges? You can see how much bytes of memory it occupies and what is the range of that particular this one. So you can see int 32 is between this range. Okay. And you also have int 64. Yeah, int 64 is this particular range. So you can see the range of that particular data also. I guess most of the cases we don't use int 64 also. Int 32 is enough if you are going beyond 32,000 range. So in that way, depending upon our data, we can use the data type to save your memory. Okay. So in this way, if you want to use int 16, you can use int 16. Happily, int 16 works for 500. But if your data is above 32,000, maybe something like 35,000, maybe if I'm storing 35,000. So here again, int 16 will not work. You can see int 16 will not work. Again, you have to go for a int 32, obviously, because your data is above 32,000. So depending upon your data range, you should use a data type that will be helping us to save your memory and optimize your things. Okay. And yeah, so this is how it works. Next, if you want to, for example, change your data type. Okay. For example, let's assume like this. Okay. First, let us assume this particular data. And let us assume that I'm using int 32 only. Okay. I'm using the data type called as int 32. For example, I want to change array data type. Then what I can do? If you want to change the data type of an array, you can use arr dot as a type function. There is a function called as a type. As type indicates that to change your data type to one data type to other data type. So for example, if I say as type, I want to change it to int 8, you can see your data will be changed to int 8. But if you want to update your array, you should also always use arr equal to array as data type. Okay, so if you want to update your data type, you have to use like this. You have to update your something like this. So now if we just look at your array will be updated with the data type integer 8. Okay, so if I say ar.dtype, type, it is int 8. So in this way, you can update your array depending upon your requirement. Not only int 8, you can use as type for converting any data type to any data type. Okay, so you can just explore that. In the same way, if you want to work with an unsigned integer, okay, for example, we have discussed about unsigned integer. Unsigned integer means what? If you are having a integer without negative values, if you want a data without negative values, you can use unsigned integer. So let's start with unsigned integer of 8. So you can simply say u int. Okay, u int 8. So if I say u int 8, it will be unsigned integer with 8 bits. Okay, 8 bits means 1 byte, means the range will be 0 to 255. So here I can store above 255 also. Maybe I can store 256 also. Sorry, above 255, below 255, I can store up to 255. So I can store maybe 129. That is possible here. So you can see 129 I am having. So previously int 8 was not accepting 129 because the range was between minus 128 to 127, but it is unsigned integer. But you cannot store negative values here. If I say minus 10, it will not accept minus negative values. You can see it is changed to 246 based on the conversion. So in this way, in u int 8, if you give your u here, it stands for unsigned, means unsigned in the sense only positive values. Okay, in that way you can use your unsigned integer also. Okay, so depending upon your requirement, you can use your data type when you are creating an array. Okay, and you can also convert your data type according to your requirement. Okay, cool. In the same way, we also have float kind of data type. Let's see that. let's assume that you're creating an array like this, and if your array is having something like this, maybe 4.5, okay, so automatically your entire array will be converted into, see here you're giving integers and you're giving a float. So we know that array is nothing but a group of similar elements, right? But we cannot have integers and floats in a single array. So that is the reason your array, your entire array will become float. You can see, even though it is something like this, but it is actually 1.0, 2.0, 3.0, 4.0, 5.0, 6.0, 7, 10.0. Your point indicates after point we have 0. Okay. So and 4.5. So your entire array is a float. So if you just look at your arr.d type, it's actually float. And here also we have the 64, 32. We have here also we have memory. So we have float 32, float 16, and 64. Depending upon your requirement, you can use. For example, you can, if you want to use float 60. Okay, so you can say float 16. So this is float 16 type, and we don't have float 8. So float 16 is a minimum one. Float 16, then you can try with float 32 and float 64. So depending upon, and you will be also having some ranges. You can just search for search in online for the ranges. So depending upon a requirement, you can use. So I guess float 64 is very huge. So max to max, you can use float 32 in many cases for your requirement. Okay. So in that way, you can use your float kind of data type in your NumPy array. Right. Next, if you want to work with strings, okay, how this particular strings work. Okay. So if you want to work with strings, you should give your strings, let's assume like this, hello, okay, and something like Python, something like, so I'm giving a random value of a strings in a list, and let's see how it will convert into an array. Okay, test. So random values I'm giving in a list here, random text string values, and I'll not give it a data type right now. So it is created right now. So here we have an array of all strings. And if we just look at the data type, this particular data type has slightly a different way. So first thing, you have a symbol here, like it's a less than symbol, and you have something called as U, capital U, and 6. What is this indicates? What does this indicates basically? Basically, this less than symbol indicates that how the data is storing in the memory, guys. Okay. So every symbol has its own meaning. Sometimes you might see less than, okay, sometimes you might see less than, sometimes you might see greater than, sometimes you might see sometimes equal to symbol also. So depending upon your hardware, it shows. So less than symbol stands for little endian, okay, little endian. Okay, greater than symbol indicates big endian, and equal to symbol indicates default hardware. So these are the methods of how exactly these particular strings are stored in the memory. So we don't have to go depth into this particular concept right now. We are not going that depth into the what is exactly little endian, how exactly is stored, but it is completely related to the bits and how exactly your bits of data is stored in the memory. So basically we have a concept of MSB and LSB. So based on that it is stored. But I just want to show you what is the meaning of this. The main idea behind this particular symbol is to tell us what kind of, in which way this particular data was stored in the memory. That's it. Next, this U indicates the data type. So basically U stands for Unicode string. So basically here we are working with strings, right? We are working with strings. So here U stands for Unicode strings, and obviously 6 is nothing but the memory. So you can see the, in particular in our data, the maximum length of the string is Python, that is 6. That's the same length you can see here. By chance, if I remove Python here, you'll be getting 4, because the maximum will be getting 5, sorry, because the maximum length is LO right now, it is 5. Okay, so you'll be getting 5. If I remove Python, you can see. So it is nothing but the maximum length of the string present in this particular, this one. It's a memory. It's how much your string is occupying. So in that way, you can explore your data type of string. So here less than stands for how exactly your uh, data type is stored in the memory. Your data is stored in the memory. U stands for Unicode string, and 5 stands for your memory. As simple as that. That's how array. That's how your string is stated in an array. Perfect. Next, for example, if you store an array something like this, if you have an array something like this, what happens? Here we clearly know that array is nothing but group of similar elements, right? But here you can see here I'm giving a dissimilar elements here. I'm giving a what we call, I'm giving a strings, I'm giving a integers, I'm giving a float, right? But what happens here is I'll not get any error. But if I just look at my array, what happens is your entire data will be converted into string. You can see LO we have, data we have, test we have, and this is 1, this is 2, this is 3, but it is converted into string. It is not no longer a integer, and it is also converted into a string. No longer it's a float. So in this way, your entire data will be converted into string, and you can see it is U5. U5 means Unicode string. So in that way, your array is a group of similar elements. We can say like this. Perfect. So we have understood about the various data types present in the array. Perfect. Now let's see how to do some kind of manipulations in array. Okay, like first thing, let's start with indexing. Okay, so for this I'll take a small data set. Maybe I'll take this. Okay, perfect. Now let's see how can we do some indexing. So basically array supports indexing, guys. We can do all kinds of indexing here. So you can see like this. For example, if I say ARR, and for example, if I want element, for example, I want the first element. So I can say ARR of 0. I'll be getting the first element. For example, if I want the third element, so I can simply say ARR of 3. I'll be getting the third element. So all this kind of indexing is possible. You can see it is 4.0. For example, if I want to get the last element, you can simply say ARR of -1. You can get the last element as usual, because -1 indicates the last index. In the same way, not only negative indexing, it also supports this all kinds of slicing. Maybe I want elements of 2, 3, 4. Maybe like here I'm having 2, 3, 4, right? So 1, 2, so and so. So 1, 2. So it is 3 is 2 and 4 is 3, right? So I should say 4. 1 to 4 means I'll be getting 2, 3, 4, obviously. So all these kinds of array manipulations and slicing is possible. Like whatever slicing you have done in list, the same kind of slicing you can do in array also. That is possible. And the next thing is array is mutable. And obviously array accepts duplicates also. First thing, array is mutable. Okay. The proof for this is, for example, your array is something like this, and if you want to manipulate your array, for example, if I say array of 3 is equal to 10, you can see the third element became 10. Third element was 4 actually, but if I say array of 3 is equal to 10, so in the same way, in the existing array only I'm able to change. So I can say array is mutable. Obviously, array can accept duplicate values. You can also check that. For example, if I try to add 1, 2, 3 here, it will happily accept without any problem. Okay, so that's cool. Next, array supports indexing. Array is mutable. We talked about all these points. Next, now let's see some of the functions of arrays. Okay, what are the functions we generally have in arrays? So first, let us see how to insert some data into the array. If you remember, guys, in list we talked about a function called as append, right? So what append does? It will add an element to the end of the list. All right, end of the list. In the same way, in arrays also, you have a function called as append, and it will add the data into the end of the array. Okay, but the advantage of append function is you can add multiple appends, multiple data at a single go. Let's see that. Okay, so how do we call append function? Means you can simply say np.append. Okay, np.append. So we should not call arr.append here. We should not call arr.append, because we have the append function in the Numpy, not in the inside the array. Okay, inside the array class. So that's the reason we should call it np.append. Okay, so we should call np.append, and in this we have basically two attributes. Mainly you have to give two attributes. One is the array, and second is the values you want to append. So which array you want to work on? I want to work on arr. So arr is my array. And what values you want to append? Maybe I want to append maybe some random values. Okay, maybe I want to append 5, for example. I want to append 5 at the last. So I can run this right now. You can see at your 5 got appended at the last. So the existing array, right now this was your array right now, right? And your 5 got appended at the last. So you can use this. And right now your array will be not getting updated. Your array will not be getting updated. Your array, for example, if I say your array will be as it is like this. It will not get updated. If you want to get updated, you should say like this compulsory. ARR equal to np.append of ARR. Then only your array gets appended. Okay, your array get updated. Okay, so in this way. Next, if you want to add multiple elements, as I told you already, the advantage of append function is you can add multiple elements at a single go, right? So you can do like this: ARR is equal to np.append. For example, if I want to add multiple elements, so I can give a list like this. So 200, 300, 400, 500. So then what happens is multiple elements will be appended at a single go. You can see. So multiple elements got appended at the last, like this. That is one of the greatest advantage in NumPy we have in NumPy append. So you can see like this now, ARR, you can see your multiple elements got appended to the end of the list. Sorry, end of the array. Perfect. So that is one more important thing. Next, so here when I'm using append function, it is only appending at the last. Okay, it is only append. That is the main idea behind append function. But what happens if I want to, or what if I want to insert somewhere at the middle, or somewhere at first, or somewhere at the last, somewhere at something like that? Then I can use insert function, right? Obviously, we have used insert function of list to insert a element at a particular position. The same way we can use insert function to insert elements at a particular position in NumPy also. So what we can do, we can use a function called as np.insert. Okay, np.insert. And in this insert function also, basically you have to give three values. One is the array, second is the index which you want to insert from, and the values whatever you want to insert. We also have access right now, as we are only working with one axis, no need to worry about this. Mainly array, object, and the values. Okay, mainly three elements, three attributes. One is the array, which array you want to work with, the index where you want to insert, and the values whatever you want to insert. Okay, that's how you can work with insert. So first I want to work with array, ARR. Okay, ARR is fine. I want to insert elements maybe from the third position. So I'll just say give 3. 3 is my position number. I want to insert from third elements. And what I want to insert, maybe I'll start with maybe 500 maybe. I'll give a random number 500. Okay, you can see at third position, you can see 500 got inserted. Automatically the fourth element got pushed here. It got pushed to the next position. Okay, so you can see at third position my 10th got inserted. Okay, sorry, my 500 got inserted. So you can simply update your array like this. If you want to update, you can update your array like this, and your array will be something like this. Now, for example, in the same way, like in append, we can as you know that in append we can insert multiple values. In insert also you can insert multiple values. So how can we do that? You can simply say insert of, maybe I can say from fifth position. Maybe from fifth position I want to insert multiple values, maybe 10, 15, 20, something like this. You can do like this. So you can see from fifth position, you can see 10, we have 10, 25 and 20. Perfect. 10, 25 and 20 got inserted from fifth position in this way. So like this, you can insert multiple values also in array in a single go. Okay. So that's a cool thing. Like this, you can append and insert some data into the array. For example, if you want to delete your element from the array, right? You want to delete some element from the array, you can use delete function. So you can simply say delete, and here you have to give which array you're working on again, as usual, which array you're working on. And here this particular delete function basically deletes based on index. It will deletes based on index. Okay, so if you want to delete based on index, you can use delete function. Now let's see how can you give an index. For example, if I want to delete 500, what is the index of 500? So 0, 1, 2, 3, right? So I have to give 3 here. So you can see 500 got deleted from your array. As simple as that. Okay. So I can simply say ARR is equal to, and 500 got deleted from your array. Something like this. In the same way, using delete, you can delete multiple elements at a single go. That's one more advantage. Means you have to give multiple indexes in a list. Maybe if I give 1, 2, 3, 4. So 1, 2, 3, 4, all the indexes will be deleted. If you just look at this, you can see 1, 2, 3, 4. So you can right now it is present in this. So this 1, 2, 3, 4, these all elements got deleted, and your data is right now from here because the indexes of this are 1, 2, 3, 4. They got deleted. So you can give multiple indexes. All these indexes will be deleted at a single go. That's one more thing regarding delete. Okay. Right now you're using delete function to delete based on index. But what if I want to delete based on value? Means right now, let's assume that I want to delete 4.5. Okay, I want to delete 4.5 and I don't know the index of 4.5 right now, or I should count the index always up to 4.5. Then if you want to delete based on index, first we should note the index, right? So we don't have any specific function to delete based on the value, right? So we have a function to know the index of a particular value. So if you want to know the index of particular value, you can use a function called as where. Okay, so you can say like this, np dot where. So where is a function to know the index based on values. So that as the name says, where is your value, in which position is your value. So np dot where we can use, and I can say like this. Here in this where, guys, we have to give a condition. Okay, we have to give the condition what we want to check for. Right now I want to check for where exactly is 4.5. So I should say like this, ARR equal to 4.5. Okay, ARR equal to 4.5, double equal to 4.5. Where exactly is 4.5? Then it will say sixth. Yes, our array is present, your 4.5 is present in the sixth position. So like this, we can use, we have to give the condition in the array. With the help of this, we can do a lot of other operations also. But let us see first how to get a index of a particular value based on the position of a particular value. So you can see here, you can get the position of a particular value using where function, something like this. So you can simply say np dot where ARR, my array, equal to 4.5. Wherever you have 4.5, give me that index. So it is 6. And the advantage of where function is it can return multiple indexes also. Means, for example, you can see here, here, let me check any duplicate elements are present in this right now. No, I guess all the duplicate elements got removed. Okay, let's do one thing. Okay, we have one, right? Okay, here we have one. Okay, if I say ARR is equal to 1, if I say np dot where ARR is equal to 1, then what happens is it will return 0 and 7. Means it can return multiple indexes also, not only single index. Whereas in list, we also have, we were having something called as index function. It will return the indexes also. It will return the index function. It will return the index based on the value. But it will return only first occurring index, not the second and occurring index. But in NumPy where function, it's not something like that. It will return all the indexes. So you can see we have 0 and we have 7. So 1 is present at the 0th position and also at the 7th position. This is the 7th position. Okay. Now, for example, I want to delete based on indexes. Then what I can do? I can do like this. I can say like this, np dot delete. I can use delete only as usual. I can use np dot delete, and in this I have to give my array and I have to give this entire statement, that is np dot where ARR. So here I'm not giving an index. You can see I'm giving only the value. This is my value. Okay, I want to remove 4.5. So I'll say I want to remove 4.5. That's it. So I'll give like this, maybe value equal to 4.5. That's it, value. Or you can directly give 4.5 also, but I'm just showing you. So in that way, you can see 4.5 got removed. So I'm not giving any indexes, but I'm giving value. But by using the where function, I'm just putting your where function here. In that way, your 4.5 got removed. And if you want to update your array, you can update like this. ARR is equal to so and so, and your array gets updated as usual, right? Okay. Now let's assume that I want to remove 1. Okay. But if I say np dot where ARR is equal to 1, what happens? It will return both the indexes of 1, 0 and 6 right now. It is 6 because previously it was 7, because previously we were having 4.5. Now 4.5 got removed, so it is 6. Okay, that's cool. Now, if I want to remove 1, and if I put this particular condition there, what happens is both the positions of 1s will be getting removed. Means 0, the value at this particular position will be getting removed, and the value at this position will be getting removed. But don't want like that. I want to remove only the first position of array. Means I want to remove the only first occurrence of array. Then what I should do? I should give only 0 here, not 6. But how do I get 0 here? We should slice this. We should slice this data. First thing, if you want to slice this, what is the type of this particular data? If you just carefully observe, it's of type tuple. Okay. You are getting the type of data as tuple. You can just see type of np dot where. You're getting as tuple, right? Then how do you slice your tuple in general? How do you slice your tuple? Right? First thing, this is your first element of your tuple. So I should slice like this. I should say of 0. This is my first element of tuple. Cool. Now I have sliced my tuple. I got my array. Now in this, as I want to slice the first number, okay, first I got this, right? I got array. Now I want to slice, or I want to get the first number from this array. So I have to say of 0 again. Of 0, of 0. I'll be getting the first number. For example, if you want to remove the second number, I want to remove the second occurrence of 1, not the first occurrence of 1. Then I have to say of 1. I'll be getting 6. So I repeat once again how we have done this. First thing, whenever you call where function, it will return a tuple. And if you want to slice your tuple, you should say of 0. If I say of 0, you'll be getting this part. Okay, so I'll just say of 0 means the first index of your tuple. I'm getting this particular part. In this, I'm having two values, that is 0 and 6. 0 is your first index of your 1 and 6 is the second index of your 1. So if I want the first index of 1, I have to say of 0, obviously. If I want the second index of 1, I have to say of 1, second index. But I want to remove only the first index. So what I should do? I should say np dot delete. Okay, instead of like this, you say like this. Wherever ARR is equal to 1, I remove the first index. Okay, so by doing this way, what happens is only the first index of 1 will be getting removed. You can see only your second, right? Because I've saved 1. So if I say of 0, you can see only the first index of 1 will be getting removed, and the second index is as it is. If I don't use this way, if I don't do like this, and if I directly lay like this, both the ones will be getting removed. You can see this first one and the second one got removed, but I don't want like that. I want to remove only first occurrence of 1. Then I can do like this. Only first occurrence of 1 got removed, second occurrence of 1 is as it is. Okay. For example, if you want to remove the second occurrence of 1, then you can first occurrence is as it is, second occurrence is removed because I'm giving 1 here. So depending upon your requirement, you can give your 1 or 0. Okay. Like that, you can also remove an element based on the value in using array, using np.delete function. So np.where function is not only for this operation, these basic operations, you can do some advanced operations using np.where function. For example, if you want to find out, for example, this is an array, and for example, I want to find out the numbers which are indexes of numbers which are less than 3, So what you can do, you can also do like this: np.where array is less than 3, less than not 1, 3. So you can see the indexes of the elements which are less than 3. So these are the indexes. So you can see we have the indexes as 5 and 6. This 5 and 6 are the elements which are less than 3, right? So what we can do like this. ARR of np.where. So you can see I'm getting the elements which are less than 3. So I said what? ARR of elements which are less than 3. So I'm slicing the numpy array based on the condition. I want the elements which are less than 3. So you can see you got the elements which are less than 3. Or I want the elements less than maybe 10. So I'll be getting only the elements less than 3. You can see, well, less than 10. So you can say 5, 6, 5, 6, and 1, 2, 3, 4, 5. Okay. I'm slicing like this. I'm saying ARR off because whenever I say ARR off, I have to give the indexes here. So when I'm using the where function, obviously I'm getting the indexes, right? These are the indexes. 2, 3 is the index of 5, 6, and 5, 6, 7, 8 is the index of 1, 2, 3, 4. So here we are getting the indexes. In the where function, here we are getting the positions of the elements. If you want to get the actual elements, you should do like this. ARR of that one, you'll be getting the actual elements. Like that, you can use your where function for multiple things. So for example, if you want to combine multiple conditions, you can also do that here in where here. So for example, if we say like this, np.where, I want, let us assume the numbers which are less than 5 and maybe more than 15 or more than 20, something like that. I want numbers less than 5 and more than 20, something. I want to combine multiple conditions. Generally, how do we combine multiple conditions? We'll say like this, ARR of, let me write in a term of brackets here. That would be very important. Brackets are very important in these conditions. And we'll say like this, maybe or elements which are more than 20. Okay, so array of elements which are more than 20. So if I say like this, I'll be getting an error for sure. Yes. So here, whenever you are combining the conditions in this way, we should not use this or whatever we were using. So when you're working with arrays or when you're working with data structures, and in this way we are trying to apply some conditions to a data structure, we should not use the regular or which you are using, but we should use a symbol here. So this stands for or. This particular symbol indicates or. So whenever you say like this, yes, you'll be getting the elements which are less than 5. You can see these are the elements which are less than 5 and greater than maybe 20. Okay, so you can see I'm getting the elements which are less than 5 and greater than 20, or sorry, or greater than 20, less than 5 or greater than 20. So this particular symbol indicates or. Okay, so that's how you have to use the conditions. And if you want to apply and statement, you have to use this particular symbol ampersand. Okay, so this pipe symbol indicates or, and this ampersand symbol indicates and. So let's see how to work with and operator. For example, if I want the numbers which are less than 10 and more than 5, something like that. Okay, less than 10 and more than 5. So I can say like this: the numbers which are less than 10 and array numbers which are more than 5. Okay, more than 5 and less than 10. So you can see we have one element which is more than 5 and less than 10, and here we are using AND operator. You know, right? AND operator means both the conditions satisfy. OR operator means any of the conditions satisfy. So depending upon your requirement, you can use AND or used in this. So here we are using where function to do all those things, but without using where function also we can do. Basically, that particular concept is called as Boolean indexing. Here, so using the Boolean values, you are trying to do indexing. Okay, so something like this. For example, if your array is something like this, and if you want to get the elements which are more than 5, something like that, so you can say ARR greater than 5. So whenever I say ARR greater than 5, so wherever we have more than 5, it will return true. You can see this is true, and this false because it is not than more than 5. This is true, this is true. So wherever we have elements more than 5, we are getting true. Now, if I want only the elements, because here we are getting true and false, these are Boolean values. That is the reason we call the name is given as Boolean indexing. So here we are getting only Boolean values, and if I want only those elements which are true, then I can do like this: ARR of this. So what happens? I'll be getting the elements which are more than 5. These are the elements which are more than 5. In the same way, if I want to add multiple conditions, exactly same way it works. Okay. So for example, if you want to add multiple conditions, you can say like this: ARR more than 10 maybe, and maybe I want elements which are greater than 10 and less than 25 and less than 25. So I can simply say and. These brackets are very important, guys. If I don't mention these brackets, automatically I'll be getting an error. So the elements which are more than 10 and less than 25. So you can see. So wherever we have elements more than 10 and less than 25, we're getting true. So we have only one element which are okay, less than or equal to will make. Okay. So you're getting two elements, 25 and 20. These are the elements which are less than or equal to 25 and more than 10. So now what I should do? I should do slicing here. I should put like this: ARR of. So I'm doing indexing only, but I'm not doing a simple index based indexing. I'm doing a Boolean indexing, means based on the Boolean values, right? You can see I'm getting 20 and 25. These are the elements which are less than 25, less than or equal to 25, and more than 10, something like this. This is called as Boolean indexing. Yeah. So in the same way, if you want to find out in equal to, maybe something like that. Okay. So for example, if you want element which are equal to 10, so you can simply say ARR equal to 10. Obviously, it works. So wherever we have 10, you're getting true. You can see, and in the same way, you can slice like this. So it's very important. I mean, it's most used in many cases when you want to filter your data. This is used a lot. Okay. And when you want to get only that particular data or only manipulate that particular data, you can use this Boolean indexing. Okay. So this is how simple Boolean indexing work in Numpy, guys. And I guess in this particular session, we have discussed about Boolean indexing, and we discussed about where and a lot of other attributes. So I can say this is the end of part 1 of Numpy. So let's discuss part 2 in the next video. And in the part 2, we'll be discussing about two-dimensional arrays and multi-dimensional arrays and other functions of NumPy to create an array. Okay. Thank you, guys.